Hello, everyone. Thank you for joining us today for our webcast, Data Modeling for the Industrial Internet of Things. I'm Alex Rigetti, and I will be your moderator for today's event. Our speaker today is my colleague, Jason Wyatt, who is a Senior Technical Marketing Engineer on the Technology Platform team here at PTC. Jason has several years of experience in the IoT and has managed everything from device integrations to app development. Just a couple of notes before we get started. We would really like this webcast to be interactive, so please feel free to join the conversation. You can post questions in the Q&A pane, that widget at the bottom of your screen, and we will do our best to answer all of these during our closing Q&A session. Just in case we were unable to get to your question, we will have our team follow up with you after the session via email. And one last note before we get started, we will be recording today's webcast and we'll send the recording to all registrants as soon as it's made available. And with that, I'd like to hand it over to our presenter, Jason Wyatt.
All right, thank you, Alex, and hello to everyone out there. I'm Jason Wyatt. Just to give you some background, I've got an undergrad in computer engineering, and I did 8 years of embedded C and C++ for a telecom corporation by the name of Adtran. During that time, I went back and got my MBA and moved into technical pre-sales as well as RFP responses. Then ended up moving to an IoT wireless mesh company called Synapse, where I was primarily involved in tech sales for intelligent lighting. I'm now with ThingWorx doing content creation for their developer portal. And in fact, this presentation is largely modeled on some new content that's on the site now. As for ThingWorx itself, well, the blurb kind of just spells it out. We're a platform that serves, at a minimum, as your back end for an IoT application. For that matter, ThingWorx can also do your front end and handle connectivity to the platform. We're entirely hardware agnostic. We provide both agents and software development kits to help you making an interface to those remote devices. And we have an open REST API that's automatically generated for everything on the platform that you create. So whether you're building your application from scratch or you just want to interface with some pre-existing application and then let ThingWorx handle your IoT bookkeeping, we can help in some shape, form, or fashion. So without further ado, let's go ahead and get started. This is just a brief list of some of the topics we'll be covering today, the what and the why of data modeling, IoT data modeling in particular, and then ThingWorx specific implementation thereof. And then we'll have, as Alex mentioned, some time at the end for some back and forth. So I want to make sure that everyone's absolutely on the same page, so let's start by covering the basics. What exactly is a data model? Well, a data model is really just the way that you organize and structure the data and logic of your application. It's really a foundation on which your application is built. And with a properly constructed foundation, your application won't have fundamental issues with its stability. And just like in the real world, a properly laid data model foundation can assist in the construction of the application itself, as the data then flows logically from one point to the next. A data model is really, quite simply an abstraction of reality. You use this abstraction to organize your data and thereby standardize any individual datum's relationship to every other one. In addition, this organization defines the real-world object which you are modeling, such that one quote-unquote data object ends up corresponding to exactly one real-world object. It's done in such a way that parts can be both reusable and pluggable when building the initial design or when iterating on it in the future. Well, why should you utilize a data model? Well, a data model creates a uniform representation of all the items which interact with one another on the platform. And there are multiple benefits to such an approach, and you can see some examples listed on this slide. I in no way claim that this is an exhaustive list, but let's examine each one of them. best practices. Well, utilizing data model is simply software development standard practice. And for whatever reason, a lot of organizations seem to forget this. I mean, this is something that's definitely, taught in college, but it seems to go one ear and out the other. So if you were creating smart connected products, you'd want any predefined functional and data gathering components to be reusable. For instance, flexibility. So you want something that is both simple to update, modify, or even remove components without having to go back and do rework. Like if you had a smart refrigerator that monitors energy usage, well, later on you might want to come back in and add something else, like an expiration date lookup with a minimum of fuss. Scalability. You want to be able to clone and modify devices that are similar when changing from a proof of concept or pilot to a full-on scaled business model. For instance, with something like fleet management, you could try out a proof of concept on one truck and then do a pilot program with 10 and then end up going to full production with 1,000 or more. Interoperability. Well, any previously developed items should be able to work seamlessly with any future ones. So let's say that you had something like a smart metering application. And on top of that, or to the side of that really, you also had a fleet management application. If you can somehow get those two programs to work together, then you can send those service trucks where you need them before something flat out breaks. In effect, you've just created an entirely separate preventative maintenance application just by combining your previous other two apps. Collaboration. You want to have multiple people working on individual sections of your application without compromising the interoperability between them. And a good data model design would allow the engineers to work on those different parts of the system while knowing that the connection between the parts is going to work as expected once they've been put together into an overall solution. Seamless platform, and what I really mean here is that you're looking for a painless integration with other systems, such as something like an analytics platform or CAD or what have you. You should be able to design a product, connect to it for data gathering, analyze the running system, visualize the components from your design, and have it all tied in with real-time data. What is the Internet of Things? And maybe you've heard of it. I hope you've heard of IoT. Maybe you haven't, though. So just to try and keep it simple, IoT is smart connected products. I mean, there's always jokes about your toaster or whatever being connected to the Internet, and you can certainly do that to, I don't know, auto-order more bread through Amazon when you're running low. But where IoT really shines is in much more complicated scenarios. Take, for instance, something like an industrial farm tractor. Now, this is a ridiculously complex and expensive machine. If it breaks for some reason, you've got your money, i.e. your crops, sitting out in a field being eaten by insects or even roasting in the sun. But if you instrument that tractor, put sensors all over it, maybe you can notice that something is wrong before it puts the entire thing in the shop. Maybe there is an unusual vibration in the engine. Maybe something's overheating. You can have those sensors update an IoT application with that information to let you know that that particular tractor needs to go in for preventative maintenance before it's taken entirely out of service. Or something that IoT is really seeing a lot of traction in is the factory. I'm seeing more and more IIoT comments, i.e. the industrial Internet of Things. You take what is already a highly automated factory, and just like with a tractor, you instrument it. I mean, this has already been happening for decades, but it's typically been done with automated control systems that are highly specific to that particular factory. Not just in how it runs, which, I mean, is always going to be a one-off that's specific just for them, but in its connection mechanism, in the protocols used to talk to the machines in how that information is displayed and in how different systems talk to each other. We really need a more universal, off-the-shelf type system there, which is something that ThingWorx can provide. Well, what's different about the IoT data model specifically? And just like a few slides back, I'm in no way going to claim that this is an exhaustive list, but let's just discuss some things. Well, you've got to worry about your connectivity requirements. In an IoT application, not all of your data is going to be stored locally. You have to worry about pulling it into your main application. Does your IoT data model account for that? Or are you writing your code as if everything is stored locally in memory? The intermittent nature of connectivity. Hey, I mean, lines can go down. You know, someone can turn on a microwave, dropping part of a wireless mesh network. Have you accounted for archiving that information remotely and then sending it only when that connectivity has been restored? Data usage and the associated cost thereof. I mean, cell connections cost by usage. You need to know your protocol's requirements. If you're sending a kilobyte of data every hour, I mean, that doesn't sound like a lot, except what if you've got 100 remotes, or 1,000, or 100,000? Suddenly that can get where it doesn't seem so trivial. Scaling. Can your central server handle all this information coming in fits and starts, and then suddenly tidal waves? I mean, if you're pulling in 100,000 records from a local database, you know, that can be rough, but you can probably handle it. You know, you can make sure that your Ethernet connection, is fiber or what have you, and all of your memory and it's all SSDs. I mean, you can probably handle that. But can you handle 100,000 remote devices all trying to flood the ISP ingress line to your server? Or do you need to account for staggering who talks and when they talk? The mass of stored data, and where do you put it and how do you access it? I mean, after all this data has been gathered, where are you going to put it? If you've got each IoT device sending just 1 kilobyte of data per hour, and then you're archiving all that data for historical analysis, across, once again, something like 100,000 devices, I mean, that's already 100 megs an hour, times 24 hours, times 365 days a year. Or then what if you're expanding, and then suddenly what was 100,000 devices is 200 or 500,000? You can easily start running into terabytes of data. What about the analysis of mass data? Can your system handle reformatting all that data for an analytics program? The massive repetition of the data model structures. Your application needs to be able to spin up and interface with a huge number of devices. Can you handle stuff like name collisions? Can you sort through that entire mess? Your data model needs to account for stuff like that. So what you're really just trying to do is get a handle on a very complex system by defining exactly what it's going to do beforehand. And note that just as the machines and the systems can be the sources of data, they can also be consumers of data too. It's not just people. In order to create the proper context to consume the data, you need to put a semantic model in place that includes things as the name or the data type, the units and permissions, and ensuring that you're talking to a trusted or canonical source. And the end result of that is that your consumers need to understand or be able to understand and relate to the data across different sources. And this is what the ThingWorx Thing model tries to do. And as an example, something like a thermostat. A thermostat has, two temperatures of interest: the current air temperature that it's going to measure, and the desired temperature that somebody else has set. Now, these can be in degrees Fahrenheit or Celsius. You could have one in Fahrenheit and another one in Celsius. Not sure why you do that, but you could. They could be stored as an integer or a floating point, or once again, something like a string. Don't know why, but you could. You could call them temp versus temperature, or current temp versus room temp. And maybe the measured temperature is read only, and the desired temperature can only be set by the people with the correct permissions. the point is that it doesn't really matter as much specifics of how the data is modeled, just as long as you have a model and that all the parts of the system agree on what that is. Now, why should you design the data model of your application first? Well, let's pause for a moment. Let's turn that question around in the other direction. What if you didn't design the data model first? I mean, it's not the only option, so let's take a look at that. Let's say that you've got an idea for just a really slick UI, and you're saying, that's our differentiator. That's what's going to get us ahead in the market. You've got something that you think is so intuitive. It's like what people talk about with Apple or whatever. Well, I mean, versus a purely local program, you can't guarantee the data you want is actually there when you want it. If the data is stored on some remote IoT device, maybe that slick interface can't actually do what you want it to do. You got to take stuff like that into consideration. Or the connectivity. Now, I mentioned that I used to work at a wireless mesh company, and don't get me wrong, wireless meshes are great. They can save you tons of headaches. However, they're not 100% reliable. Any individual node can just decide, hey, I don't feel like responding for a while. And the bandwidth typically isn't that great either. If your application doesn't account for scaling and data pass-through speeds, then deciding to utilize a certain connection method before knowing what you're actually trying to send through that medium is a recipe for disaster. Or what if you end up picking your end hardware first? Let's say that there's some new piece of IoT hardware out of China or whatever, and you've said, hey, this business model makes sense at this price point. Let's go ahead and buy a ton of these particular devices. Well, I mean, how are you going to manipulate that actuator or what have you? Or maybe an actuator is too simple. Maybe it's a gateway of some type. But regardless, can it even accept the commands you're wanting to give to it? How do you even know what you're wanting to send or receive until you design your actual data model? Now, model-based development really provides many advantages. And I'm going to go out on a limb here and say that there are some particular items that you should be looking for in an ideal data model. Well, first, it should define for lack of a better phrase, a metadata model. Something that allows the consumers of the data to understand it in common, everyday terms without specific training. So instead of having to look at the data in its native, possibly cryptic form, the data model should really translate that into language that everyone understands. Next, the model should provide a consistent representation of the underlying information for your main system, as well as other tools of which you're taking advantage, and enable them to work together seamlessly, leveraging the power of the model. For example, the model could include everything about an asset, from its CAD and PLM data, to manufacturing information, to its service state. And these could all be represented and consumed in an application through the model. Lastly, as the model is built and evolves over time, it should automatically generate an API that other systems can use to gain access to real-time IoT data and other information about your physical assets. Because if you add some type of underlying functionality to your data model, and there isn't an API to actually access that functionality, it's almost like you didn't change anything. Well, I mean, hopefully the case has been kind of made to design your IoT application around the data model first. So if you're going to do that, where do you start? Well, at least in my opinion, start by identifying who is using the end solution and what do they need. Identify all the sources of your data, and remember that sometimes they aren't physical devices or sensors. You need to compose a representative model of modular components to enable functionality, reuse, and uniformity whenever you can. Define what type of data you have, as well as how you're going to store it. Examine the functional needs, and then map them to your design for proper business logic implementation. And examine the security needs for both visibility and access and assign permission visibility control to your design. Well, ThingWorx has been developing applications with our platform for many years now, so we've had to think extensively on how you go about building this IoT data model. And to show just some of the thought we put into this, here's a slide that I just blatantly stole from some of our training documents. This gives an example of one way that you could go about designing your data model. So you start with the users. Who are they? What do they need to see? What can they change? How do they go about doing their jobs? Then think about your data sources. What's bringing in data? What is that data? And how do you want to represent it? And from there, you can start to try and build your initial data model. Then end up comparing it back to your needs and see how well it actually matches. All right, so now you've got your initial data model in hand. Start to think about how your remote IoT devices send and receive data. How are you storing it? What type is it? Is it an integer, a string, or a GPS location, or what have you? Now, you're theoretically storing useful info from the remotes at this point. Do you need to do something with it? Do you need to calculate something? Does one datum combined with another one mean something on which you need to take action? And finally, lock it down. Make sure that the users can only see what they absolutely need to see. They can only change what they need to change. And, of course, document the whole thing. Create a formally reviewed spec before writing a single line of code. So how does ThingWorx specifically implement the data model? Well, the ThingWorx model draws similarities from the object-oriented modeling approach. You've got very similar concepts to something like a class, as well as instantiations of said class. And at a base level, you've got these three main types: shapes, templates, and things. So what is a thing? Because we are using this in ThingWorx specific terminology now. So what is a thing? Well, almost everything with which you will interact in ThingWorx is a thing. Most commonly, a thing is going to be a representation of a physical object. For instance, you might define a thing to represent a particular assembly machine within your factory, or perhaps something like a temperature sensor. However, things can also represent more abstract concepts, such as a connection to an external database, or a call to something like an RSS feed. ThingWorx things are therefore simply the quote-unquote things of the Internet of Things, whatever those objects or connections may be. A ThingWorx thing is really just a generic container to encapsulate the functionality of one IoT object. Things can be created as pure one-offs, i.e. ThingWorx really allows you to create a thing that is just a one-of-a-kind. And this can be helpful in situations where you only wish to interface with exactly one of that type of object, such as with something like that RSS feed. If you're already using an RSS thing to get the weather forecast, it's not particularly necessary to create multiple of that thing. You know, one can be quite enough. Well, what exactly is a thing template? Well, typically, rather than creating one-off things, we find that ThingWorx users have a wide variety of the same type of deployed real-world objects with which they want to interface via the ThingWorx platform. For instance, your factory assembly machines may all be of the exact same make and model, or at least multiple different sets of machines where each type of, contains hundreds of identical units. And in this situation, it can become both problematic and time-consuming to create a thing directly for each one of these from scratch, hence the usage of thing templates. Thing templates are really analogous to something like a mold or a pattern. If you have 100 of the exact same type of device, then it's recommended to create a thing template and then instantiate individual things from that template. And this recommendation is for a variety of reasons. For one, it's simply going to save you time. For another, it can be rather helpful in development or troubleshooting or even continued expansion of your IoT application. When you modify a thing template, all the things that are created from that template are modified simultaneously. So when you have a large number of instantiated things, that means that you're making one modification, period, instead of one for each thing you've created. It also prevents accidentally skipping a modification in one or more of your devices. To provide a coding analogy, modifying a thing template to change functionality is similar to modifying a function which you've stripped out into a separate section. If every other area of your code simply calls that function, then only one modification is required, i.e. in the function itself. If instead you re-implement the code wherever it's needed, then you would need to modify the code in every single one of those separate areas. And this can obviously lead to a development nightmare. The usage of thing templates, therefore, is highly recommended whenever there are multiple instances of effectively the same type of object. And finally, there are thing shapes. While thing templates are molds for entire devices, which encapsulate all of that particular device's functionality, thing shapes are really more analogous to subcomponents. As an example, if you return to the assembly line machines, perhaps there are 3 different types of machine, and each one has 100 machines per type. Well, likely, just like I said, you're going to model this in ThingWorx via creating 3 thing templates and then instantiating each one of the individual things from each one of those templates. But perhaps every machine has a battery, and this battery was 100% identical amongst each one of the templates. In the same way that rewriting functionality wasn't recommended in the thing template example, likewise, rewriting a description of the battery functionality in all 3 thing templates wouldn't be recommended either. Instead, the battery could be extracted out as a thing shape of which each thing template would then make use. So just to recap, here are our 3 main entity types. Once again, templates are very much like a class, shapes are like an interface, and then things are an object or instantiation from a class. All right, so how thing templates and thing shapes work together can be a bit of an overwhelming concept, at least at first. In general, though, it can really help to imagine them like an assembly line. Thing shapes assemble individual components. Thing templates combine those components into fully functional objects. And then a thing is a unique representation of a set of identical components that have been created from that thing template assembler. And to put it in a graphical form, it roughly looks like the slide you're looking at right now. Of course, this isn't to say that your own model has to be anywhere near this complex. I mean, quite frequently, things are just created from thing templates without utilizing thing shapes at all. And you can have things that are just created directly, like I mentioned, without using a custom thing template. Or alternately, thing shapes may be added to things directly in order to modify a particular one-off thing in a way where the modification itself is still reusable. So our thing templates may actually inherit directly from another thing template. For instance, you might have some kind of semi-generic thing template for a machine, which then ends up getting inherited by a more specific thing template called an assembly machine. And then in that case, the assembly machine will have all of the common machine elements from the parent, but has then also added additional functionality that is specific only to assembly versions. And you're basically ending up in a parent-child type relationship when you're doing something like that. Well, so If that didn't completely drive the point home, like here's a real world example. If I remember to advance the slide. All right, so once again, real world example. So at the top, you've got one master template, and in this case, it's a collection of similar types of tractors. In addition, that master or parent template has a few different shapes that it's inheriting. This could be because they've been used in previous designs, maybe the last generation or something. So importing them as shapes allows us to reuse previous design work. In this case, you've got an engine and a deck that are both just carried over, so just use the shape. From there, we've got 3 different child templates, one of which is also incorporating another shape, this time in the form of a GPS device. And then all the way at the bottom, you've got all the individual, quote-unquote, real-world tractors. These are actual specific tractors with individual serial numbers that are going to be sold and report the connected data back to an IoT application. So you've got your shapes, you've got your templates, you've got your things. Now, that determines how ThingWorx at a really high level creates the data model for your IoT application. But what about the low level? How do you define that you're storing a temperature versus something like a pressure value? How do you cause an actuator to close a valve? How do you throw a flag that some value is too high and reaching a danger zone? How do you respond to that error flag and actually do something about it? Well, in ThingWorx, we do that with properties, services, events, and subscriptions. So what is a ThingWorx property? Well, properties are likely the most straightforward out of all these elements, in that they're exactly what they seem to be, i.e. it's a set of physical properties that describe the object. For instance, a thing shape describing a battery, like we already mentioned, might have various properties including weight or capacity, voltage, amp hours, the brand, whatever. A thing template, or thing shape may have any number of properties defined, and each of those properties may be of several different data types, such as a string or a number, an integer, a Boolean, a location, a date and time, an image, and so forth and so on. Each property that you add to a thing template, or thing shape further describes the object. Properties added to a thing template or a thing shape are propagated into anything instantiated from them. This is getting back to that, and this holds true with everything, property, service, event, subscription. So anything that you're adding to a thing template or a thing shape, if the actual thing is being built from that template or shape, it's going to inherit any changes that you take to it. What is a service? Well, services are functional blocks of JavaScript code that can be added to a thing, a template, or a shape. Services end up performing business logic, typically, related to your data model. For instance, returning yet again to our battery thing shape, you might wish to calculate the watt hours of that battery. And the watt hours itself might be another property, but rather than manually entering that information, you want to actually calculate it from the previously entered voltage and amp hours. Well, to do so, you could create a service on the battery thing shape that multiplies the voltage by the amp hours and then stores the result in that watt hours property. Now, I mean, that's a rather trivial example. We're just doing some simple multiplication, but there's really no limit to what logic you can create using a service. For instance, you might have a service which activates a switch to turn on a warning light when the battery's capacity falls below a certain threshold. In addition, that same service could then generate an email to a service technician requesting maintenance, while also logging the error in your application's blog as a record of the event. Now, events. So events are very similar in ThingWorx to interrupts in coding parlance. They're triggers that can be fired when certain situations arise. Events are typically used to bring attention to some state that has just been reached and needs to be acted upon immediately. But I do want to clarify that events are basically just placeholders. In essence, they are the warning flag rather than the situation that caused the flag to be lifted or the action that you want to take. For instance, tying back yet again to our battery thing shape example, you might define an event as battery too low. A service which dynamically calculates the battery's capacity and monitors that levels for a threshold violation could then generate the battery too low event when that threshold had been exceeded. At that point, the battery too low quote-unquote flag has now been raised, and other process can act upon it. Once again, though, the event itself doesn't do anything, such as call a service to log the issue. The event's simply an announcement that a particular state has been entered or an occurrence has happened. To do something when an event is triggered, you want to have something monitoring it, which leads us to subscriptions. Subscriptions are how you monitor events and actually do something when they're triggered. Subscriptions are therefore similar to a function that's called when an event or an interrupt fires. And similar to services, subscriptions use JavaScript code to define what you wish to do when the event goes active. In essence, a subscription is simply a triggered service. You know, the only real difference between a service and a subscription is really their method of being called. Typically services are going to be called by your application, while subscriptions are going to be called when an event fires. And it's perfectly valid to have a subscription do nothing more than call a service, because then you're getting some reusage of code. For instance, yet again, tying to our battery thing shape example, you could have a service, not subscription. You could have a service which deactivates a contactor, end up cutting power. And you could call the service for any number of reasons. Like you might call this cut power service just when a button is pressed in your application. However, there are all kinds of other reasons where you might want to trigger that exact same service. Like you could have an event for the temperature's gotten too high. And then a subscription to that event could do nothing more than call that exact same cut power service that's also being triggered when somebody clicks a button. So the service is being called for different reasons, i.e. an event rather than button press, but the result ends up being exactly the same. So just in general, an event subscription combination should typically be used whenever you need interrupt-driven behavior. So to summarize, yet again, a thing and the thing model is used to represent most any type of object. It's the digital representation of a physical asset or system. And things are defined by property, services, events, and subscriptions. Things are created typically from thing templates because you're wanting to create a whole bunch of effectively the exact same type of thing, whereas thing shapes are a set of a subcomponent, a reusable characteristic that you're wanting to use about many different, possibly disparate things. So the slide you're seeing now is at least one recommendation that we could make about how to design a data model using the ThingWorx version of the data model. You end up simply asking yourself a series of questions. Is it a one-off, standalone? Okay, then just make a thing directly. Or is it a whole separate component that's used in multiple other devices? Okay, make a shape. Or is it a group of items of which you have multiple? So then make a template. Or is it a group of items that are related to some larger group but are more specific? Then end up making a child template that inherits from that parent template. Well, one of the central value propositions of ThingWorx is to increase productivity and time to value for IoT solution development, as well as deliver easy-to-maintain solutions. Thing model helps support this by eliminating the need for developers to have to build and maintain a database schema or write low-level code for common tasks such as data ingestion, translation, and then triggering business logic. They're able to leverage the model to link connected things with other business systems so they can interoperate and understand each other. Model-based development means that your workflows and related tools simply, quote-unquote, click in to the model, creating a central brain or heart of the platform. For example, it's quite easy in ThingWorx to move from using Google Maps to using OpenStreetMaps because the data model for both widgets is exactly the same. The Thing model enables what you want to do with IoT, such as optimizing business processes, understanding usage characteristics to improve future generations of products, detect anomalies and predict failures, or optimize maintenance and repair for your connected products, and then enhance the customer's experience by integrating compelling applications that complement the physical product, operation, or environment. So hopefully you're now saying, hey, that sounds great. How do I get started? Well, that's really quite simple. Go to developer.thingworx.com. We have tons of tutorials, hosted instances of ThingWorx that you can use for up to 30 days, or we've actually also got a free for download ThingWorx instance that you host yourself that can last for 120 days. We've got links to the community site and everything you really need to start building various things. In addition, we've got links over to our developer community, which is a great resource where everyone from new to experienced developers ask questions, they can collaborate, and you can get that to that developer community through the developer forum. And like I said, all of the content you've seen here today about data modeling is available on the site at developer.thingworx.com/data-model. And now, we've still got some time. We're just going to open up for questions. And I think I heard Alex.
Yeah, sorry. Just want to jump in. Thank you so much, Jason. That was great. Yeah, as Jason just said, this is the time now for you to ask any questions that you may have. Please feel free to submit them through the Q&A pane. Again, that's the widget at the bottom of your screen. And we actually do have a couple of questions that have already come in during the session, so I would say we get started with these. So the first question that I have here for you, Jason, I'm sorry. Using ThingWorx, how would you break down a complex scenario like smart lighting?
All right. I love smart lighting. I don't know if this question came from me mentioning that I was working in an IoT company doing smart lighting, but the way I would typically do something like this is model each one of the lights as things. You can have properties for stuff like your on-off state or your dim level. And then you would have services for, I don't know, calculating the time of day. And then you might have events that are throwing a flag when, I don't know, a motion sensor input has said that, hey, there's somebody within my area. And then you would have a subscription that pays attention to that event saying, okay, go ahead and call the change dim level service and move it up to 100% or whatever because there's somebody within my range. So there's your property services events and subscriptions, but it's almost guaranteed that you're not selling one of these. So you wouldn't do it as an individual thing. What you would do is you would take those property services events and subscriptions that you figured out that you need and put them all into a template. In fact, you're probably selling multiple different types of smart connected lights. Like you might have a bollard, you might have a residential street light, and then you might have like some super high-powered like interstate street light. So what you're probably going to do is have 3 different thing templates, and each one of those thing templates is going to further define and specialize on what particular light you're doing. So now you've got multiple different templates, and maybe you use a shape, maybe you don't. If there's something that's out of those 3 templates is common to 2 of them, like it's the exact same functionality, okay, that might be something that you pull out into a shape, and then that shape ends up pushing down into two of the templates, but not into the third one. And yeah, I mean that's pretty much going to be it. You're going to have a couple of different templates, and each time that you sell or install or ready to connect one of these IoT connected smart lights, you just instantiate a new thing from the appropriate template, and there's your data model.
Awesome. Thank you, Jason. I have more questions coming in here for you. The next one that I have here is, how do you ensure interoperability between different IoT platforms?
Between different IoT platforms. Okay, well, we've got a couple of different ways to do that. And honestly, this brings up something great that I should have actually had in the slides. If you're not that familiar with ThingWorx, we have the ThingWorx Marketplace. And the ThingWorx Marketplace is primarily there to put up extensions, which is yet something else that wasn't quite covered, or was outside the scope of this particular presentation. But ThingWorx is not just what you get when you install ThingWorx itself. We also have a way to automatically extend functionality without you having to upgrade to some new version of ThingWorx. It doesn't have to get necessarily rolled directly into the, for lack of a better phrase, main branch. And the way that you do that is via extensions. And the ThingWorx Marketplace has tons and tons of extensions that change or modify or add on to the functionality that the core of ThingWorx actually has. So, for instance, like let's say that you're using an Amazon device cloud. Well, guess what? There's already a ThingWorx extension out there on the marketplace to help you do stuff like that. Or whatever other IoT platform you're talking about, the answer by and large is going to be something like an extension. Well, the next immediate follow-up question is the ThingWorx Marketplace doesn't have an extension. And don't get me wrong, we've got tons of extensions, but the Marketplace doesn't have the particular extension that I need. Not a problem. There is absolutely nothing stopping you from writing your own extension. In fact, we've got guides up on the developer portal walking you through how you write your own extension. So if you're running something that's either relatively exotic or fairly new, and we just don't have something pre-constructed on the marketplace, you can extend the functionality of the platform by creating an extension. There you go.
Awesome, thank you. Next question that I have here for you, technically not really a question, but would you mind bringing up the decision tree up again? I think that was slide 27.
Sure. Well, we had two different decision trees, so it depends on which one you're talking about. I'm guessing it's this one because, this was the decision tree.
Slide 27.
All right. Yeah, I like this one because it's. I'm sorry, please go ahead.
Nope. If you can maybe just give another overview. There weren't any more questions, but yeah, just go over it again.
Yeah, sure. So on this particular slide, the earlier, it wasn't so much a tree, it was a process flowing through about how you should create your initial data model. That was really high level, and like that wasn't even ThingWorx specific. This one is really very ThingWorx specific. It's just giving you a very quick guide about when you should use a shape versus when you should use a template versus where you should instantiate a one-off thing. And it's just ask yourself these questions, and you're going to get a pretty good idea of how you should go through it. Now, this is really high level. There are going to be gotchas in this particular one. Once again, I recommend going to developer.thingworx.com/data-model. That's got, once again, these slides were created, from some of the content that I and some of my colleagues wrote that's on the developer portal now, and you're going to get much, much more in-depth breakdown of when you should be using what and how exactly you go through that process.
Thank you. And the next question that I have here for you, how to handle heterogenic data in ThingWorx. For example, if temperature sensors send data in degrees Celsius and another in degree Fahrenheit, how to interpret them and bring them to a standard unit followed across my application?
Sure, absolutely. Good question. Primary way that I would do it off the top of my head is with service. So you would have basically a placeholder property for, like let's say that you wanted to standardize on Celsius. Maybe you're doing some type of a scientific application, but you got some sensors. And this is tying back to what I said about, starting with buying your hardware before you've really got your data model in place. You ended up purchasing a whole bunch of sensors that are feeding you data in Fahrenheit. Well, your data model ended up getting developed afterwards, and you're kind of assuming everything is in Celsius, or so you need to get it standardized. What I would probably do is have that sensor go ahead and feed in the Fahrenheit, and you store it in a temp property. And then you have a service that comes in that modifies, it's just standard calculation to go from Fahrenheit to Celsius. Now, how are you going to call that service? I would do it by an event. That event would trigger whenever that incoming temp variable changed. So an event's going to fire saying, hey, my temporary Fahrenheit property just changed to a different value. So now the event's in the air. You have a subscription that's paying attention to the event that says, okay, it just changed. Now I'm going to go and call that service to convert the Fahrenheit to Celsius and then store it in another property that is, converted. So just with a combination of property services, events, and subscriptions, you can quite easily do an automatic conversion, a standardization, whatever you want to call it, from one data type to a different one.
Great, thank you. And next question that I have here is when creating a thing directly from a REST API command, how do you enable the override with REST API without touching ThingWorx Composer?
Sure, absolutely. Yet again, go to developer.thingworx.com. We've got a wide variety of, wouldn't really call them tutorials or quick starts. They're more how-tos. We've got a section of how-tos that just answer short little individual questions like that on how do you do it via the REST API instead of using ThingWorx Composer. So, the actual discussion of the specific methods of doing that are a little outside of this discussion, but, there are guides on there for this is how you create a thing, this is how you create a template, this is how you create a shape, and it's all done via REST API. You never touch the composer.
Awesome. Thank you, Jason. Next question. ThingWorx, I'm hoping I'm getting this together the right way. ThingWorx uses an agent on the thing I read. Is that a agent Kepware or something else? Also, if ThingWorx is running on a server, it does get to the agent. Does it get to the agent? I guess first question, is that an
Yeah, there's a couple of different questions there. I think I've got them all, but we're going to see. This is going to be a wide-ranging answer. Okay, so as I mentioned way early in the slides, don't even really remember where it was, but ThingWorx helps you out in several different ways in terms of connecting to your remote IoT device. One way that we do it is via the agent. It's called the Edge Microserver, or EMS, and the agent is a precompiled software binary that you can just stick on your various IoT systems. Now, it does have some requirements. It's not that big. It's not going to take up that much memory. It doesn't take up that much processor utilization. But you do have to already have some type of operating system running on there, obviously. So you install this agent. You configure it in the scripting language. It takes whatever inputs you're giving it, a temperature sensor or something like that, and ends up sending it up to the ThingWorx platform. And actually, yet again, developer.thingworx.com, our Raspberry Pi, don't remember if it's a quick start or a tutorial, but just look through our stuff for Raspberry Pi, actually just got updated like last week or something like that to walk you through not only connecting the Raspberry Pi using the EMS agent, but also connecting an external temperature sensor. Actually, I think it's a temperature and humidity sensor. So that's a great way to have us walk you through. This is the way that you use the agent to get the information up to the platform. That's not the only way you can do it. We absolutely do not require you to use the agent. We've got software development kits in a ton of different languages. C, Java, .NET, iOS. I'm sure I'm probably forgetting some. And this is just raw source code that you can either just compile directly and run as a separate process, or you can actually integrate the source code directly into your source code and then just compile it as one big whole thing. And at that point, you're just doing function calls. Now, it's using the exact same protocol that the agent is using to send information up to the server. It's just, as opposed to a pre-compiled that's coming from us, it's something that you're doing yourself. So that's another way that you can get information into the platform, is via the SDKs. Then the third way to do it is what we've already mentioned in the last question, is you can just do it via REST. You can just do REST calls to push and pull information to and from the platform. And we really make no distinction whatsoever. Do it via an agent, do it via an SDK, do it via REST. We don't care. Just get the information into the platform, then you can do something with it. I don't know if I covered every single question there, but there's at least an answer.
And we can follow up via email. I think we have 3 minutes left. Maybe we'll cover one more question if we can make it short. Jason, another one that I have here for you is, how would you account for mass data? Properties seem good for individual items, but what about huge databases?
How do you account for huge databases? Okay, well,
yep.
A couple of different ways. First off, you can just make a JDBC connection to a remote database. And actually, this is kind of tying into some content that I'm actually developing right now, yet again in the data model series, but this one's going to focus on storage. Probably still a couple weeks out before it gets pushed to developer.thingworx.com. But yeah, if you've got a ton of mass data that's sitting externally in some shape, form, or fashion, you may just want to keep it on the database. You don't have to pull everything natively into the ThingWorx platform and push it directly into a thing and store it as properties or what have you. You can just leave it as an external database and just make the JDBC connection and then just push and pull to the database as needed. But there's other situations where the concept of mass data kind of comes in, like property history. Like, let's say that you've got that temperature value. Maybe it's connected via Raspberry Pi, or maybe this is a full-out industrial application, and you've got your own hardware and whatever else, but you're pulling in a bunch of temperature values. It's completely possible that you want to plot that information over time. Well, one of the ways that you can do that, and once again, this will be covered in that future piece of content that's coming out, is with what we call a value stream. And value streams are a really, really super easy way to say, I want to keep track of every time that this particular property is changed. And it's really just trivial to do it in the platform. You create a value stream, and all the value stream is really just a place to store information. You tie it to a particular thing, which is a couple of clicks in the platform, and then you go into the particular property, and there's just a checkbox that says logged. And then every time that property changes, it's going to have a date time stamp as well as what that value changed to dumped into that value stream. And it's just trivial to get long-term history. Besides that, you've got the concept of streams, which are kind of like a more generic value stream. They don't have to be tied to a particular thing. In fact, if you have a situation where you have tons and tons of these temperature sensors out in the world, and you want to aggregate all that information into one location, a stream is how you'd end up doing that, because it's not tied directly to a particular thing, so you're not using a value stream. Then besides that, we've got non-history stuff, which is data tables and info tables, and that's usually used for mass static data. I can't really go into a more in-depth answer because I think we just ran out of time, But
Yep.
yeah, so check back on the developer site in like 2 weeks, and I'll have a better answer for you.
Great. Thank you so much, Jason. Unfortunately, we've come to the end of our webcast, as Jason just said, and I know there are still a couple unanswered questions, but as I promised at the beginning, we'll follow up with you individually via email. As of now, I'd just like to thank everyone for joining us for today's webcast. We will share the recording of this webcast via email once it's made available. And also, if you do have any other questions and didn't have a chance to ask them yet, please feel free to either post them in our developer community or send us a note via our contact form on our developer portal or on the ThingWorx website or LinkedIn or any other social media platform. I really hope that you found today's session valuable and will join us again for one of our future webcasts. Thank you so much, everyone.
Thank you, everybody.